So I'm going to talk about the greenhouse effect. I'm sure you've heard about it 1,000 times before, but I want to talk about how we know what we know. How do we know that greenhouse effect exists at all? Stuff like that. And we can thank astronomers for that, because astronomers are the ones who first discovered what the greenhouse effect was. So, everything in our solar system starts with the sun. Without it, there wouldn't be life on Earth. It provides life and warmth to our planet. All major ecosystems on Earth start with the sun, but it can kind of be a double-edged sword because if you have too much light, then the planet gets too hot. Case in point, Mercury. Mercury is the closest planet to the sun. It has no atmosphere. So on the daytime side, it can get up to 800 degrees Fahrenheit, whereas at the nighttime side, it can get to negative 280 degrees Fahrenheit. These temperature fluctuations are caused by the fact that Mercury has no atmosphere, so it's really bad for the planet. Venus, on the other hand, is twice as far away from the sun, but it maintains constant 870 degrees Fahrenheit, hotter than it ever gets on Mercury. The reason for this is because Venus has a very thick atmosphere composed almost primarily of CO2, about 97% CO2, and it's a very thick atmosphere, so it traps a lot of the heat, and it's incredibly hot. Even farther from the sun is Earth, us. It's a pretty planet. It has a very thin atmosphere with relatively small amounts of CO2, but because our atmosphere is so thin, a little bit of greenhouse gas goes a long way. So, what is the greenhouse effect? Well, light of all wavelengths hits the Earth from the sun, and the light gets absorbed by the ground and radiated back up as infrared light, which is basically heat. So, greenhouse gases trap this light and reflect it back towards Earth, heating it up. So, the more greenhouse gases there are in the atmosphere, the hotter it gets. And since our atmosphere is so thin, a little bit goes a long way. There are other greenhouse gases than just CO2, but we'll just stick to talking about CO2 for now. So what are some of the effects of the greenhouse effect? Well, there's glacial melting. So, as you can see here, the glaciers melt, and other than the fact that they're not as pretty, it actually has major devastating consequences for the ecosystems in that area and for the climate as a whole. So, like I said, our atmosphere is very, very thin, and here it is. This is a picture taken from the International Space Station of actually a sunset. So that thin blue line, that's our atmosphere. It's very thin, and a little bit of CO2 really does go a long way in such a thin atmosphere. Oh, such a pretty picture. Okay, so we're currently at about 395 parts per million of CO2, which doesn't sound like a lot, but it is. We're climbing rapidly. We increase by about 2.4 parts per million per year, and the rate of increase is actually increasing. So it's basically exponential, and it's a really bad situation. So why is it always CO2 that we're talking about? Well, it's because CO2 is the one greenhouse gas that's directly related to burning fossil fuels, like gasoline and coal. And so we know that we're causing this. It's no debate that humans are causing climate change. So white ice at the polar caps, yeah, it easily reflects the light, but when the ice melts, it expands the surface area of the dark oceans, which in turn absorb even more heat, and the cycle accelerates. So, people think, global warming is kind of a misnomer, because it doesn't mean that the entire planet, everywhere, just gets hotter. It means that things become more extreme. So, hotter areas become hotter, and colder areas may become colder. It's a runaway greenhouse effect, and it's hard to predict. So one thing that we know is that tropical storms like hurricanes, typhoons will become even more extreme because the hotter water actually is fuel for the storms. So they will become stronger, more intense, and it will cause even more destruction and devastation. So how do we know what we know about the greenhouse effect? Well, it's hard to predict these consequences because the ocean currents, the air cycles, they're all extremely complex. As you can see from this image, it's of ocean currents. They're extremely complex, and we use computer simulations to try to figure out what's going to happen. But it's really hard to predict. Basically, it never ends well. So, the only way to cut our dependence on CO2 is to switch to sustainable energy such as wind, solar, geothermal, things like that. And we have to completely stop our CO2 emissions. But what do we do about the CO2 that's already in the atmosphere? We can't depend on the oceans, which absorb CO2 and absorb heat. We can't depend on those because when they do that, it actually harms the ecosystems in that area. It destroys coral reefs, and it just messes up the ocean currents and all the life that lives there. What we can depend on is photosynthetic organisms. So phytoplankton and trees and flowers, whatever, they all turn CO2 into oxygen, which is definitely good. So, but when we destroy those, we have even less of an ability to absorb CO2 and turn it into useful oxygen. So we really have to work to protect phytoplankton in the oceans. We have to work to prevent deforestation because that's our only hope in reducing the amount of CO2 in the atmosphere. And that's just what we have to do. So we live on this tiny planet in the middle of nowhere in space. Out of all the planets and all the stars in the entire galaxy, this is the only one we know about. So if we screw it up, we can't go anywhere else. We have to make the right choices, and we can't screw up our planet.